Hello and welcome to another video on gold, and today we're looking at the actual formation of gold. So here I have a good website, Earth Resources, and this has just a basic introduction to how gold is formed in Victoria. So if you want to go to the website, Earth Resources, very good. So Victoria is a world-renowned gold province and a variety of styles and world-class pre-competitive information. So the world's class central goldfields province has produced 2,500 tons of gold, so 80 million ounces. That's quite a lot of gold. So 80 million, what's the actual value of the actual gold for 80 million tons? So I'll just take an average gold price of $2,000 times 80. That is $160 trillion. No, $160 billion, sorry. So $160 billion. That's quite a lot of gold that's actually been mined in Victoria, and a lot of it can still be found. Okay, most of it is orogenic. So orogenic means it's related to mountain building, and that's when two land masses come together and are being pushed together. Then you have mountain building, so mountains rising up. But you also have the rock being pressed down into the mantle, and that would cause the rock to be deformed, and that's what we call metamorphism. So heat and pressure are changing the rock. So orogenic gold deposits that form during regional deformation, so that's the mountain building, and metamorphism, so the heat and pressure, the late Silurian and to the late Devonian. Current production, so exploration expenditure remains buoyant, and gold production as well, so it's pretty relevant. Production in Victoria is currently in an order of 650,000 ounces per year. Per annum is per year. Coming mainly from the Forestfield, Ballarat, Coastfield and Storwell. So there is a map. So we got the Forestfield up north. We have Ballarat. It's not on the map, but it's the lower part of the red area to the west of Melbourne. Where Ballarat is, just go north and you've got Bendigo. Coastfield doesn't show on the map. I'm not too familiar where that place is. I will soon. And Storwell, so going towards Grampians. Okay, Victoria has 13 goldfields that have each produced more than 1 million ounces of gold. So Bendigo's the largest, followed by Ballarat, Castlemaine, Storwell, Woods Point, Walhalla, and many Victorian goldfields offer opportunities for newer discoveries through the application of modern geoscience knowledge. So since the 1850s, we know a lot more about how gold is formed, where it's most likely going to be found, but because we have a sparing analysis of the underlying geology and how it changes underneath. So we know pretty much in the surface geology, but not the rock underneath, because it changes quite a lot. But from education, you can get an educated guess of where the actual gold could be. And geoscience knowledge and mineral exploration techniques and technology. So the purpose of these videos is for me to learn about the gold deposits. Whether I go out and look for gold, I don't know, probably. Okay, now we have a picture ore body drill hole that is at 12.5 meters, and it contains 500.7 grams of gold per ton. So that is quite a lot of gold. Usually you get percentages that are lower than that, but that's about 0.5%, so per ton. And there we have the map. So the red areas are the larger gold deposits. Then you got down to the yellow areas, which are the lower gold deposits. And the different colours, you got the Bendigo zone, you got Stawell zone in the purple, Bendigo is in green, and Ballarat zone as well. Melbourne zone is in blue, and then you got the Alpine zones over in the Alps. That's a little bit more inaccessible because a lot of that is still forested and unpaved roads, so you generally need a four-wheel drive to get to a lot of that area. But Bendigo and Ballarat is pretty accessible, but a lot of it is on farmland, so you need farmers' permission. You can't just walk on their property. Okay, then we've got gold deposits. So this is orogenic. So Victoria is one of the world's largest orogenic gold provinces. Orogenic, what's that orogenic? Orogenic gold deposits represent by far the most economically important primary gold mineralizations in Victoria. Okay, most of the deposits are folded, faulted and regionally metamorphosed Cambrian and Devonian turbidites. So if you're not too familiar what a turbidite is, here we have some pictures. So this one, we have the side of a continent. So the brown we have is the land, then we've got the rivers coming down. The dark blue is the continental shelf, and then it goes the continental slope and the deep sea. So the turbidites are when the sand just flows down into the deep sea via gravity. So as you can see, the deposits get a lot thicker and wider as you get down the continental slope. So that is what turbidite is. Here's a picture from Wikipedia. Just looks like sedimentary rock, which pretty much it is, and it's got laminations. And here is a bathymetric map of 4 turbidite sources in the it looks like the Mediterranean, so you've got Egypt. So the turbidites are flowing down into the deeper part of the ocean. That's the blue arrows. And there's another one of that map. There's sedimentary strata. So this has different layerings. Does this have turbidites? Not too sure. I haven't looked at it properly. So anyway, that is what a turbidite is. And you go just looking at images of the internet via Google, you can get a lot of information. Just look at the images. So here we have, so this is seismic section up north and the bottom up top, and the bottom part is their interpretation of what it is. So you've got a lot of faults in it as well. So that is turbidites. And if you're not too, and it says they're from green shift facies. So green shift is metamorphosed volcanic rock. So that's basically what it is. And it could be secondary deposits from the erosion from the land. So this green shift. So here we have the pressure and the temperature. So green shift is about between 300 and 400 degrees Celsius, and pressure is about 1.5 to 8 atmospheres. Oh, what is that? Kilobar. So that is what they've used. And you've got different types of rock. So you can look that up yourself. Okay, so they are found less commonly in Cambrian metavolcanic and sedimentary rocks, and also Devonian dikes. So different types of geology. Mineralization is associated with late stage of regional metamorphism, or in part a reactivation of older structure. Timing, character, and intensity of orogenic old mineralization vary considerably in Victoria, bear a close relationship to the geological history of the structural zone of the state. Okay, so in the early stages of the mountain building, there was no mineralization in the rock, so and the timing is a character of older mineralization. Yeah, I'm not too sure what they're trying to say there. That's something I need to learn. Okay, and then there's two types of deposits. It's mesozonal and your epizonal. So if you look at the bottom paragraph of mesozonal, it says mesozonal orogenic gold deposits precipitate from low fluid liquids at a depth of 6 to 12 kilometers. Epizonal is the same, precipitation from low salinity fluids at a depth of 2 to 6 kilometers. So epizonal can be deposited at the same time, but between 2 and 6 kilometers. Mesozonal is between 6 and 12, so at greater depth. And so mesozonal temperatures will be lower, 170 to 300 degrees Celsius, and they're deposited in the Melbourne zone, Bendigo zone. And the mesozonal have high temperatures because they're greater depth for 300 to 475. The main phase of mesozonal orogenic mineralization is Bendigo, Stawell zones, around 440 million years ago, and at Melbourne zone at 380 million years ago. So we're not too sure the date of the mesozonal because it doesn't show here. Oh wait, it does down below. Yeah. So 380 million years old. So okay, so we need to read that all together. So you got all this. I'm not going to read all of it, so probably freeze the screenshot or go to the website and read it yourself. Then we got epizonal. Read this as well. Pretty much the information is pretty similar. Okay, then we got golden volcanic host massive sulfide deposits, so volcanic rock. And best known is Currawong copper zinc deposits. Now I'm not too familiar with these volcanic host massive sulfides, so if you're not familiar, then try and read up about the Currawong gold zinc deposits and the Mount Ararat gold zinc deposits. I'll do that in another video. Okay, and gold in these deposits are associated with pyrite, chalcopyrite, and sphalerite at grades of 0.5 gram to 1 gram per tonne. So this is quite lower than the rocks they found in the picture, which is the Lower Phoenix zone, which is at 500 grams per tonne. So you can see the difference. And then we have intrusion related. So this is not related to mountain building, or could be in part. Okay, several small intrusion related gold deposits have identified in Victoria. These are spatially and temporally related to felsic intrusion, so the intrusion of granite, because that's a felsic rock, have characterized geochemistry and formed later than other styles of gold mineralization in Victoria. Unlike the orogenic gold deposits, they were deposited at considerable time after the main local mountain building phase. So these are probably like the rocks around Donna Buang. So those ones. So we're talking about. Oh, where are we talking about? Need to go, Matt. Yeah, probably in between Melbourne and Walhalla, that type of area. So if we go down again. The Wangdong deposits at Storwell is the largest intrusion-related deposit in Victoria. Yeah, related workings. Gold in intrusions-related deposits is in quartz veins. So you need to find a quartz vein, and usually you'll find gold as well. So you don't just find gold in quartz, you can find it in nether rocks. And these deposits commonly have amorphous concentration of molybdenum, tungsten, bismuth, antimony, copper, tellurite, and sometimes tin, boron, and fluorine. So they're associated with other minerals. The magmatic source of the intrusion related is unclear. In particular, deposits hosted by metaturbidites and characterized by gold values exceeding 30 grams per tonne, up to 510 grams per tonne, and many attributes to some. Okay, so the high gold deposits may be the mountain building phase and not the intrusion. Okay, the intrusion occurred from 370 to 380 million years ago in Melbourne and Bendigo zones, forming 400 and 420 million years ago elsewhere. So, and then we have the alluvial deposits. So that is the deep leads or the former rivers that have been covered over, and that is the yellow part of the map up the top. Okay, alluvial deposits in Victoria are formed by weathering and erosion of primary gold mineralisation. The largest value deposits are typically close to major orogenic gold deposits. So where you find the orogenic gold deposits, you'll find that probably some of them have been eroded and it's just been transported downriver. That's basically all they're talking about. The quartz veins or the rock in sedimentary rock, the gold, has been eroded out, taken downriver, and at a certain point the river will lose a lot of energy and that gold will just drop out, and that's where the gold has been found. However, several major alluvial gold fields are in areas where only trivial primary gold deposits are known: Creswick, Chiltern, Arrow, and Beaufort. Total Victorian alluvial gold production is estimated to be 1,500 tonnes, but historical records are poor or non-existent, so there is uncertainty about this number. So it could be higher, could be lower, we don't know. The largest alluvial gold fields extend over distances around 10 kilometres and produce more than 100 tonnes of gold. So in these videos I go through the maps and you can see all the areas that have been excavated or gold is found, and a lot of these areas have not been dug up, but a lot of it is also not accessible at this time. Most alluvial deposits are traced to their primary source and thus lead to primary gold mineralisation. To date, no significant primary deposits have been mined in Victoria, have been found by any other means. Most alluvial gold is hosted in Eocene to Holocene gravels, so they're the older river courses. I'm not talking about the Pleistocene. So the current rivers in their current flow rates or flow patterns probably don't have that much gold in it. If you can find an older water course connected to the current one that's been filled in, that's probably a good way to metal detect there and see if that actually has gold. The grain size of alluvial gold varies both within and between deposits and is probably related to properties of the primary gold mineral source mineralization. So if the water coming up, the saline water coming up, only came up, I don't know, for a few thousand years, the gold deposits are probably small. If it was a few million years, then the gold nuggets are probably quite large. Or even if the gold in the water was greater or less. So there's lots of variabilities that would affect the size of the gold nuggets. Some areas in central and western Victoria are well known for abundance of gold nuggets. So I'll go through the and then there's the rest of the map. So, and you can download everything. So Gold Undercover report series. So if we look at that, and they're all free. So you can just download. I just put education because that's basically what it is. And in it says there's like saddle reefs. You find a lot of saddle reefs. And yeah, I think this computer's dying. So this is a saddle reef. These are areas that you can find gold in. Basically, a saddle reef is, that looks like a saddle. So it follows the sedimentary strata. And it's just where the mineralization has pushed the two stratas away from each other to fill the gap. And you can see the black line is a fault line and it's in an anticline. You can get them in synclines, but you can get them in different structures. And that will be I think this is the end of the video. This computer is not really that good. Okay, so this is a 2D seismic refraction data along a 400 kilometre transect of Central Victoria in 2006. Yeah, including controls of orogenic gold, mineralisation and consideration of mineral deposits. So this is showing where the gold deposits will be. And line 1, 2, 3 and 4 are where they done the transect, and they use a truck for that. And here we have an interpretation of the information they got. So the underlying geological structure under the ground. And you got lots of other information. So this is a good site to use to look for gold, or even just to learn about it. And also there's fossicking as well. So I'll leave this here if anyone wants to watch it. Thank you very much. If anyone wants to correct me, please do, and have an awesome and banknote, geological finding gold so they can make coins and convert it into banknotes. Thank you and goodbye.